is Nurul Ain binti Salimun. So my group choose the topic about green theorem. Okay, firstly let me show you what is green theorem. Green theorem exists specially for closed loop line integral. So first we take the general equation from line integral, which is integral of c of p dx plus q dy. Because this is closed loop, automatically we will obtain a region that is D. So from line integral equation, we get the double integral of D of dq per dx plus dp per dy dx dy. Okay, before that, we have to acknowledge that there are two situations in this theorem. It is important because they are different in terms of orders. If the curve run counterclockwise, it yields to positive orientation, while if the curve run clockwise, it yields to negative orientation. So, what is the difference? Okay, let's look on formula. For positive orientation, we use this formula instead, and for negative orientation, the terms are reversed. That's all.
Hi, my name is Nurul Nazira binti Nursan. I will show you step 1. Listen carefully. Okay, first, let's notice that if we walk along the path in the direction indicated, then our left hand will be over the enclosed area. And so, this path does have the positive orientation, and we can use Green's theorem to evaluate the integral. From the integral, we have p equals to yx squared and q equals to negative x squared. Remember that p is multiplied by x and q is multiplied by y. And don't forget to pay attention to signs. It is easy to get in a hurry and miss a sign in front of one of the terms.
Hi, my name is Nur Amira Shafika binti Aman Shah. So I want to show you the solution for step 2 of this question. Okay, so from this question, we can see we have a semicircle region, which is it runs counterclockwise, and we have the region is on our left. Okay, since the region is on our left, it is a positive orientation. Okay, so this is a closed loop region. So we use Green's theorem to solve this question. Okay, for positive orientation general formula, it is given by double integral of d of dq over dx minus dp over dy dA. Okay, which is dA, which is we have to integrate in terms of area of the region. Okay, so from the question, we have the line integral of c yx squared dx minus x squared dy. Okay, so from the line integral, we have to convert to the Green's theorem formula, which is the double integral. So after we convert, we get the double integral of d 2x minus x squared dA. So the dA is represent the area, so we can write it as dy dx or dx dy. So where is the value is come from? Is from the partial derivation, the partial differentiation of p component and q component as stated at step 1. Okay, so for p component, we differentiate in the terms of y. So we differentiate y, we get 1. So so we get the answer is negative x squared. While when we partial differentiate the p component, so we get negative 2x. Okay, so that's all from me. Let's continue for the step 3. Thank you.
Hi, it's me again, Nurul Ain. So now I will talk about for the step 3. Okay, from the previous step, D is the region enclosed by the curve. Since D is just a half of circle, it makes sense to use polar coordinate for solve this problem. The limits for D in polar coordinates are D is greater than 1/2 pi but less than 3/2 pi, and the R is greater than 0 but less than over 5. That's all.
So hi, my name is Nosha Sofia binti Muhammad Zuiden. So I will present for the last step, which is step 4. So for this step is after first converting to polar coordinate of the cos. So we need to solve this problem is to evaluate this double of integral, that what we call evaluation word from the step 2, which is using Green theorem. Integrate of y(x squared dx minus x squared dy equal to double integral of negative 2x minus x squared dA. So don't forget that we have the arc from converting A to polar coordinate. So make sure that you need to recall the trigo identities, which is we need to replace this at equal to arc cos theta. So from the set 3 is we know that we got the D is the region which is the limit of the integral, and for the second integral we got 1/2 pi to 3/2 pi, and for the first integral we got 0 to 5, and we need to integral of r bracket negative 2r cos theta minus r squared cos squared theta bracket dr d theta, and then from this equation is we got negative 2r squared cos theta minus 1/2 r cube bracket 1 plus cos 2 theta dr d theta. So from this problem is we need to integrate of 0 to 25, which is we got from the integrate of dr negative 2/3 r cube cos theta minus 1/8 r4 bracket 1 plus cos 2 theta bracket the limit of 0 to 5 and d theta. And then from this problem is we need to replace the r, which is 0 and 5, and then we got the answer is negative 250/3 cos theta minus 625/8 bracket 1 plus cos 2 theta d theta. So for the second integral is we need to integrate of d theta, which is we got negative 250/3 sin theta minus 625/8 bracket theta plus 1/2 sin 2 theta bracket, and the limit is we need to replace of theta, which is 3/2 pi and 1/2 pi. So we got the answer is 500/3 minus 625/8 pi. So the final answer of this problem is negative 78.7703. So this is the answer of using Green theorem, and thank you for watching.